Hello and welcome to this R-Instat video comparing station and satellite data using graphical comparisons. Our starting point is the merged data from 4 stations in Germany. These data are available in the R-Instat library in a file called Germany for Merge. These are the data from the previous video, which merged the station and satellite data. We start by right-clicking in the station variable to make it into a factor column so that it's recognized as categorical. Next, we use the climatic, dates, use date dialog to generate some further variables. The date is filled automatically. We add 4 variables and press OK. This used the date variable to create 4 new columns as shown. They add the year, the month, the day of the month, and the day of the year. Now we can start the comparison. We make use of the climatic compare menu, starting with correlations. We add 2 variables, sunshine data from the station and sunshine data from the satellite. Then we select options and choose scatter matrix, using station as the factor. The results look very good, rather exciting even. The top right shows the correlation at each station are very high. The top left shows the shape of the distribution of sunshine hours at the station. The 4 lines are close together, so the pattern is similar for all the stations. The exciting result is that the shape is also very similar to those of the satellite data in the bottom right. Although the correlations are high, there are days, possibly at each station, where there's as much as 10 hours sunshine at the station, but 0 or little estimated sunshine from the satellite data. There are a few, but less the other way round. We shouldn't get too excited yet, because we've currently ignored the seasonality in the data. Return to the correlations dialog, then to the options, and change the factor to the month. The results remain very encouraging. The correlations are still high, particularly in the summer months. With shorter days, the range of data is less in the winter months, and that is one of the reasons the correlations are often lower. The shape of the distribution of sunshine hours depends greatly on the different months. This is no longer an ideal display of the data. Our main aim is to compare the station and satellite data, and here they're on separate graphs. So we move on to the next item in the compare menu, scatter plot. We complete the dialog using the sunshine satellite data and the sunshine station data. Use the month as the variable and go to plot options. Include facets and use the station as the first factor and the month as the second. Return and OK. This gives 48 plots. We transfer them to the R window and maximize to examine the results in more detail. In general, this looks good. Most of the values are on the main diagonal. This also shows that the oddities with the correlation plot were mainly in the winter months. They were at all stations, but particularly at Graphical. Here they extend into March. Now let's look at the seasonal pattern in more detail. Use the compare menu again and the seasonality plot. We fill it with our sunshine data variables using the day of year for the seasonality and the station as our factor. There are lots of options here, but we choose to just use the defaults. The indication here is that the means of the station data are close to the satellite estimates, particularly in the winter months. In the summer, the station data has, on average, more sun than estimated from the satellite, with the bias being about 30 minutes a day. In the next video, we quantify these differences with numerical summaries. There's also a supplementary video to examine the data from one station further. Thank you for watching.